Explain like I'm 5. What does it mean when they say folding a piece of paper 42 times will reach the moon? I have tried Googling this, and I simply don't understand how this works. Folding a piece of paper 42 times is equal to the distance between the Earth and the Moon, and folding it 103 times would be larger than the observable universe. I'm not understanding how folding a piece of paper is equal to these large distances. It's impossible to actually fold a piece of paper that many times. You wouldn't even get to 10 most likely. This is because every fold is doubling the thickness. So one fold is thickness x2. 2 folds is thickness x2 by 2. 42 folds is thickness x2 42. 242 is 4,398,046,511,104 sheets of paper. An example you can more easily try for yourself is the rice on a chessboard. Put a rice corn on the first field. Double what's on the first field for the second. And so on. Just thinking about it, you don't think it's that much rice. Trying to do it, you will soon run out of rice. Calculating it to the 64th field, you will realize that more rice than atoms in the world, or something like that. If you are strong enough to fold a piece of paper in half 42 times, you can walk into NASA headquarters and force them to put you on the next rocket to the moon. Edit: I'm legally obligated to mention I'm just messing around. Thanks anyway to the helpful replies. I love a good discussion on materials science. The folding is perhaps a distraction. When you fold a piece of paper, it arguably gets twice as tall, because you stack half of it on top of itself. The width of the paper doesn't matter, just its height. So we can replace fold with double the number of sheets of paper in the pile, and the height should be the same. So, if you take one sheet of paper, and then double the height of the stack of papers 42 times, that is what allegedly reaches the moon. 42 doublings is a huge amount. So I wouldn't be surprised if this were accurate. 242 power 4.4 trillion. So take a piece of paper 0.009 centimeters, 4.4 trillion 395,000 kilometers, which is more than the distance to the moon, 384,400 kilometers. There is an old Chinese story that is similar, where someone wanted to buy something, and the seller said, I will accept payment in rice as follows. We will take a chessboard. Place 1 grain of rice on the first square. Double it. 2 on the second. Double it. 4 on the third. Double it. 8 on the fourth. And so on. By the end, there isn't enough rice in China to pay the bill. The last square alone would have 9,333,372,854,775,808 grains of rice, plus the rest of them. The way to approach finding paper and distance is to recognize that every step doubles the previous value. An easy exercise to check your understanding of exponential growth is to answer the following question. Every day, the population of lily pads on a pond doubles, increasing the coverage of the pond's surface each day. By day 20, the entire pond is covered. How many days does it take to cover half of the pond? You gotta think of it more as an exponential growth exercise than actually folding a piece of paper. If you can do it, though, please do get it on video. Every time you fold something in half, you double its thickness. Folding something in half n times, if its original thickness is t, would give you something with a thickness of t2n. The exponential function 2n grows very big very fast. So this reaching the moon thing is just another way of saying that. It has to do with the fact that every time you fold a piece of paper it gets twice as thick. Even though paper is really thin. Doubling anything 42 times will make it unimaginably huge. Folding a piece of paper 42 times doubles its thickness 42 times. So if it starts out as 1 mm thick, it will wind up 4.4 million kilometers thick. The moon is only 400,000 kilometers away though. So you'd only have to fold it 39 times, it would then be 550,000 kilometers thick. The important part is that you are folding it in half every time. You can put 42 folds in a single sheet of paper. No problem. But folding it in half means the number of sheets is doubled. Without that stipulation, the number of folds is meaningless. Double the thickness of a piece of paper 42 times and it will be thick enough to reach the moon. That's literally what it means. If you fold a piece of paper, you are doubling its thickness each time. Say an average piece of paper is 0.1 mm thick. To calculate the thickness of the paper after 42 folds, you have to do 0.1 by 242. Which after conversions works out at 440,000 kilometers. Which is longer than the distance to the moon. You're doubling the thickness of the paper wad with each fold. Start at like 0.1 mm guesstimate and multiply it by 242. That's essentially what they are saying. Every time you fold something you double its width. If you continuously double any number it grows exponentially very fast. Basically each time you are folding the piece of paper, you are going to be doubling it by its current width. It might take 10-25 doublings for it to get to a width that starts to make a difference. But very quickly after that it will explode in size hypothetically. And further double itself until it reaches the moon. When you fold a piece of paper that's xmm thick, you get a piece that is 2xmm thick. When you fold it again, you get a piece that's 4xmm thick. Do that again and you get a 8xmm thick piece. Fold the paper 42 times and you get a piece that's 4,398,046,511,104 xmm thick. Exponentials. 2 is 4. 28 is 256. 216 is 65,536. 232 is 4,294,967,296. 242 is 4,398,046,511,104. Multiply that by 1 mm. And that's 2,732,819.4 miles. Now, you can't really fold paper that many times. There's not enough mass. Nor could the material be bent stretches to that extent. I believe the limit is 7 folds. This is more so a hypothetical double the width of a piece of paper 42 times. Instead of folding, imagine cutting. You take an A4 piece of paper. Cut it in half. Stack the two halves on top of one another. Now take that stack and cut it in half and stack again. 4 pieces of paper 2 by 2 or 2 2. Again. 8 2 by 2 by 2 or 2, 3, 1 6, 2, 4, 3 2, 2, 5 etc. until you do that 42 times 242. Multiply that number by the thickness of a single piece of paper. And boom. Moon.